Okay, this is the second part of the overview for
Yeah.
steel special movement frames. This portion is most of them are competitor review.
Yeah.
What are we competing against, and who's out there in the market, and how do they compare against ours? What are their selling points to people? Why do they want people to use them?
Yeah.
And what kind of advantage they have over ours or over each other? And how do they buy it? And what kind of support they have to the engineers? So this would cover a lot of those. So, and then following by that is, okay, our connection, overview, our limitations, advantages, obviously, and with you guys, how do we sell it?
Yeah.
And currently, we offer a one-story frame similar to the OMF. Those are starting, are launching that in January of 7 of next year. So, our SMF has not been launched. So
Yeah.
we've been selling it selectively, but we haven't go out to market yet.
Yeah.
So next year,
Next year.
yes,
Yeah.
January 7th, we're gonna put out a
Launch.
catalog, press release,
Yeah.
and everything.
Flyer.
Flyers and email engineers that
Yeah.
okay, we have this system for you to use.
Yeah. So,
So-
we start our service.
Yep. So yours probably comes a little later, but I don't think it's the first day.
Yeah.
You'll see
Yeah.
many requests.
Yeah.
But you won't start that. So multi-story, multi-bay, then we'll need your support. Like for the engineers, I'm going to give them a spreadsheet for the one story and two stories.
Yeah.
So they don't need to bug you with those
Yeah.
those two story or one story. But anything that's not in there,
Yeah.
then they'll have to supply and get you guys the stuff and the potential markets and what we have. So competition. I got this slide from one of the branch engineers. They do the training, to see where you are, who do you stack against. So, who's our competition? Okay, and there's a big one. Also competition. So,
Yeah.
this is also a slide from branch 20 for their selling. So, it's know your enemy and know yourself.
Yeah.
And 100 battles you'll never be defeated. Whatever they got this one from. No, just know your enemy. Okay, so our competitions in this moment frame there's plenty. I think the one that for light frame construction, residential, we probably competing with the side plate. Okay, Paco's got some.
Yeah.
A lot of them, surprisingly, actually from engineers that design their frame, they have specifier on it.
Yeah.
Okay, then
Design by themselves.
but designed by themselves, the detail by themselves. Okay, you don't need to convince them to use our frame.
Yeah.
We have sales guys that out there to do that, and how we save them time, save them time for
Yeah.
the design, and save them money if they use our frame. That's our sales guy. But
But
for you guys, you
yeah.
should basically understand that there's engineer frames out there that they call out the RBS section or the bolted flange plate section.
Yeah.
Those designs are probably most likely the engineer design.
Yeah.
Okay.
But when the engineer design by themselves, they don't have the test requirement. It's a test. Yeah.
That's why when they design it themselves, they would have to go with the 358.
Yeah.
350 has a list of the pre-qualified ones,
Yeah.
so they don't need the test.
condition.
Yeah. So if you use this one,
yeah.
pick one to
Yeah.
use,
Yeah.
and then detail it. Yeah. So that's all it is.
Yeah.
So I'll go into those a little bit deeper. Yes, for the engineer designs, they would have a list of connections that
Yeah.
pre-qualified that they could use and to select from.
Yeah.
So that's what the 358 document is.
Yeah.
I'll bring one in later this afternoon to show you what it looks like.
Yeah.
So the first one is the Kaiser bolted bracket.
Yeah.
So you'll see it on the drawing. This is actually extracted from the drawings. This is their bracket. That's basically what they're selling. So they have 1, 2 brackets, one on the top, one on the bottom. Like I say, this is bolted through
Yeah.
and is welded to the beam. So the bracket is a steel bracket. They weld it to the top and bottom,
Yeah.
and then they ship it out to the site, and then you bolt it together.
Yeah.
Okay, so this is they have the W series. W series is basically welded to the beam.
Yeah.
They have the B series is basically bolted to the beam as well. So they allow them to do either way.
Yeah.
So they have these two series of connections that's offered by Kaiser bolted bracket.
They,
So
they build the bracket first and they
Yeah, so they just like ours, they build their bracket first,
Yeah.
and then they ship it out to the
Yeah.
to the fabricator, and the fabricator will either weld it
Yeah.
or bolt it to the beam. So
Yeah.
they only sell the bracket.
Yeah.
They don't sell anything else. They just they sell the bracket, just like our link. This
Yeah,
is the
just
bracket.
sell the bracket.
This is the bracket that
Yeah.
they sell. Okay, they
Yeah.
provide the services to use it,
Yeah.
but that's what they're selling. That's just this bracket.
Yeah.
So how this bracket attaches the beam, these are the two methods: welding it or bolting it.
Yeah.
Okay, so they could claim that everything they do is welded or replaceable, or if they whatever they want.
Yeah.
But I'll show you some of the
Yeah.
the advantages or disadvantages later. So they use these in hotels,
Yeah.
okay, offices, even hospitals, schools, casino, airport, some seismic upgrade. Very few at this point are private residents, but they are. We just saw their website. They're offering kind of like what we do for our OMF, one story, one bay. They're offering theirs as well, so it's competitive to our SMF. So they ship it out, offer it as a frame, and so no, they see business. They're not turning down, so they're making this. Making it run at us as well. So that's one of the competitors that they have. They're starting to offer standard sizes connections and frames. When we talk about their limitations, I'm basically going to go to the beam and the column. They are allow up to a beam that's 33 W33, very deep. Weight 130 pounds per linear foot. Compared to ours, our beams are W16. Okay, we don't have any weight limit, but we're W16, so we are essentially half the size as them in terms of the beam depth. So they're very up. The flanges on the beam is 3/4. Ours are thick flanges up to, okay. We have a 0.4 inch limitation, so a flange has to be 0.4 inch thick. Yeah, so 0.4. So that's what ours. They also have a limit of how wide the flange are, so they could fit these brackets to it. So how wide this is. So for the W is 6 inches. For the bolted one, they would have 10 inches for this dimension. Okay.
And why do we have those thickness and depth limitations on ours?
The depth is due to just mostly testing. We haven't tested anything bigger. The flange thickness is actually how the connection fail. They're forcing all the failures out to the beam. So if the flange is too thick, then they're not able to buckle and dissipate energy. So they cannot go too thick. So that's why those are the limitations are. The weight, the pounds. These are coming mostly from testing. So if they haven't tested anything bigger, then they're limiting them to that. And these are coming also these are just geometry requirements for how big the brackets are. If they weld it, they could be smaller. If they bolt it, then they have to space it out a little bit more. Then they need wider flanges. Clear span to depth ratio. We don't have to meet this one. I'll go to that a little bit. But theirs is 9. What this means is clear span is how far the beam goes divided by the depth. So the depth is if you have let's say 100-inch span, and your beam is 10, then the clear depth to span is 100 divided by 10. It's 10. So theirs limited to 10 or greater. Okay, and this one is for, you don't want it to be so short that failure and shear could happen all the time. They want it to be flexible and failure as a fluxual failure, so your fluxual hinges. So if you get so much smaller, at that time your failure is going to be in the bolt, in the connection. So that's what these limitations are. And you'll see some of it for a lot of different systems. We don't have this to meet. Our design procedure basically designs it, incorporates this span to depth limitation in the check of our connection. So again, lateral bracing needs to be provided per AISC. So obviously, the bracing is needed, and I'll show you why bracing is needed in all these connections later. So the columns, when there's a concrete slab, the columns could be 36 inches. Okay, when there is no concrete slab, the columns are limited to W14. And the reason for that difference is when you have a concrete slab, your column, they're restraining the column from twisting.
Yeah.
So if you that's why the thicker the greater it is, the easier for the column to twist.
Yeah.
So if you have the column, the concrete slab, it prevents it from twisting.
Mm.
If you don't, then you can't prevent it from twisting. But that's why you can't use it so deep. You only allow you 14-inch maximum at those times. They also, you could do build-up boxes, so a box column, and that could be 16-inch wide or 16-inch deep for those columns. Okay, so those are the column limitations for them. So I mean, if you see it, if they're outside of this range, you might want to just bring it up or something. That could be one thing that some of them might. But I think the design should have it meet it. But just show some of the limitations. The bracket to the beam, fillet welds. Okay, they welded the bracket, but because it's a casting material, they need a special welding procedure. So the fabricators have to be specially qualified to weld it. And then when they're bolting, okay, when bolted to the beam, they need to put because of the cast material, they separate that into the steel with some kind of brass washer. So different material. So again, it doesn't need to know it very well, but it's just that these are a little bit more complicated. Not just welding the bracket to it, but in terms of welding it, how do you weld it? There's a lot more requirements when they do that. And then when bolted the flange, 1 inch thick by 1/4 inch washers needs to be used opposite side of the beam. I think there's a detail I showed it. So there are also more washers to use as well. What they typically do is they shop weld the beam to the brackets to the beam, and then bolt it to the flange in the column in the field, because it's a lot faster.
Yeah.
So if you imagine those steel workers out there, all they want to do is just put the bolts in and then turn it and good. So they don't want them to weld in the field. Yeah. Too costly, and
they weld at the fabricator.
Yeah, they weld in the shop. The difference is we call it shop welding and field welding. Field welding is where you do it outside. Yeah. If you're rain or wind, then it's kind of hard to get good quality weld. So in the shop, it's controlled environment, just like our shop, and inside, no wind or any environment would affect it. So the shop welding. So what they typically do is like I said, shop weld it to the beam and then field bolt it to the column. Yeah. Okay. When you use it, there's no licensing fee. They don't charge an engineer a licensing fee. So how do they make money? Well, obviously they sell these brackets. Yeah. That's how they make the money. They do provide engineering details for free. So if an engineer asks them for the detail, they'll provide it. Yeah. They have passed the AIC 358. They're in the pre-qualified document, and they also have used it for OSHPAT. OSHPAT is for the hospitals here. It's very strict for when you're using something. Yeah. So that's probably the most strict requirements is from hospitals. Yeah. So they have used it for retrofit.
It's a special requirement for hospital. Yeah.
Yes, when you look into even design for seismic design, there's an IE factor. Yeah. Hospitals is 1.5. Residential is 1. So when you're designing for hospitals, you have to design for 50% higher the force. Yeah. So that's the difference between hospital and residential. Basically, how engineer uses it is engineer to design and specify it on the plans. So what you see is you're going to see the drawings on a set of plans and specifying use Kaiser bolted bracket, whichever series, and then when you get the set of drawing, then you know, okay, that's an SMF that we could try to replace or something. So that's what it is. No licensing fee. The unit costs include bracket and bolt. So they sell the bracket and the bolts. So that's how they make the money. Okay. So when we try to convert it, you'll see it on the drawings. The engineers will specify it on the drawing. So that's how you know that that's a Kaiser border bracket when we're trying to convert it. The second system, this is more of a for high rise and a little bit more heavier than what we try the market we're trying to go out at this time. But it's just still another competitor. Like I showed before, all they're welded the beam, welded the column, with CJP weld. But what they have here is a big slot. So the slot is very tight in terms of geometry to tell you what to do, and also the shear tap here needs to be welded. So this shear tap needs to be welded in the field. Okay, this needs to be welded in the field. This needs to be welded in the field. So it's very field welding intensive. So it's not bolted. It's not easy to bolt. So all these have to be welded in the field, and that's why this probably hasn't been very, I guess, popular option for steel people to use. But it is one of the competitors. We do see it before for use. So hotels, a lot of offices before they use this connection. So high-rise offices. They use also medical, retail, warehouses. Retail is where you have a shop selling cell phones or whatever in the bottom. That's and the recreation facilities like gyms and so on, pool cover, warehouses. The beam limitation, they're pretty big. Also, most people goes to 36. 36 is pretty deep. 300, it's very, very heavy. Yeah. So and the columns for Oshpot or the beams is pretty specific for the columns. The maximum is 383 for 14. 256 for deeper columns. Anytime you use a deeper column, they have the stringent requirement because you don't want it to be twisted. So bracing for beam is required. Column, they test it from 14 to 176 all the way to 14 by 550, including the 36 series. So this is pretty much, I would say, no limitation on the beam column per se, because the range is so wide compared to what we have. Ours, the column is a W18 maximum we could do. So not 36. Ours is 18. Only half of what the maximum. So that's just to let you know what the ranges are. So obviously, field welding a beam to column. This is very, very strict, and that is a limitation to them because if you do it in the field, if it rain, you can't do the welding. If it's too windy, you can't do welding, right?
We have to wait.
You have to wait, or they have to put some protection around it, and then all the workers have to tie off safety. If they do a higher, drop. So that's where a lot of field welding, and also not just that they're doing it, but also inspection. Inspectors have to inspect it afterward. So those inspectors are expensive too. So field welding is a disadvantage. Most of these connections. Backing bar removal and then reinforcing the filler weld required the beam bottom flange. Let me show you what the backing bar removal requires. This is the blow up detail. They call this the backing bar right here. They have to remove it, or on the top, or you have to put in the reinforcing. Remove backing bar at filler weld. Remove backing bar at filler weld.
To fix the location.
They don't want to put a stress concentration. So when they do the CJP weld and when they're welding down, they need something on the back so it doesn't drip through. Typically, they're prepared. There's a gap when they're trying to do the two together. On the bottom, they put a bar and then just tag it on. And then when you weld on it, then your middles wouldn't go through. And then after you finish up the weld, then they will have to go back and remove and grind off this back up, and then after that they put a filler. Okay, so imagine in the field somebody's doing it overhead. Okay, that's very hard to do. So that's one of the limitations for them. Again, I kind of lumped the field welding and field inspections together before, but field inspection is also a limitation. Shear tap, PJP, the column flange, and then beam web needs to be filler welded to the shear tap. What this one was is, if you look at this is called a shear tap, or shear plate, or shear tap. People use it interchangeably. interchangeably. So this one, when they weld it to the column, this has to be a CJP weld. Okay, you see, call this.
Yeah.
And then after they weld it, this one they have to weld it to the beam in the field as well. Okay, so this one they could do in the shop. This one, the CJP, but when they weld to the beam, this one has to be on the job site. So a lot of welding on the job site for this one. So that's some of the limitations. Slotted web, no, they typically right after Northridge earthquake. That's when most of the testings were done. At that time, the fabricators and engineers were very familiar with them. They say they're easy to fabricate. All they do is cut the slot. Yeah, easy to fabricate, but not easy to install, put together. Okay, so they distinguish easy to fabricate. Extensive testing. They did a lot of testing. OSHPAT approved. They have a COE report as well, and they basically passed the AISC seismic provisions. They claim have no lateral bracing at the beam column connections required. So when we talk about beam bracing, there's actually two locations: beam within the span, and beam bracing at the beam to column connection. So there's two different requirements. One is along the beam, and the other one is at the support. So they say there's no bracing at the connection or near the support region. Designers, how they do it is designers will design the moment frames and the connection because they don't weaken the beam too much. So you use the regular beam and section. Designers design it. They call it on the drawings. What they do is the designers will submit the drawings to them, and these guys would generate within 2 working days a set of AutoCAD drawings for the details of each connection. Okay. This is per project. This is an old number. They charge regardless of the size before. I don't know what it is. It's $40,000 per project, and also based on percentage of saving. If you have a bigger project, they're going to charge you more. If you have a small project, they're going to probably charge you less. But they do charge you a licensing fee because they're not selling the bracket. They can't sell it. All it is the process. The design. You just put a slot there. So it's design. So they're selling the design. So they charge you a licensing fee. Okay. So no nothing special. So that's called a slotted web. So side plate is our competitor for the ones for residential. What they switch is this one instead of the Y flange. They have a tube section. I'll show that. I think there's some slides later. This is their typical application, beam to column, but they have also claimed to be brace connection, also 2 directions. That's very important, bidirectional. Currently, our connection, we have not tested for 2 directions. Okay, so we could only do 1 direction where the column and the beam comes in this way. Okay, only this direction. We don't have anything that comes in this way, so we don't have this connection. So if you see anything on the plan that has 2, then you might have to ask the engineer to, either do something about it. Add another column, or not count on the bay or something. So that's very important. When you see on the plan, we could only do single direction, not bi-directional. Okay, so they come in this way, they come in that way. They say they're okay, but look at the column. See that they welded something to go this direction. So we could potentially do that too if we weld it, but we just have not done the testing. So it needs to be tested. Their market is the offices, hospitals, medical centers. Surprisingly, and what they sell and go after are the government buildings. GSA, a blast. Like all the embassies in U.S. embassies and in other countries, they just try to sell this connection because it's good for blast. If there's a terrorist attack, when they take out the column, this connection is continuous across. The column will not drop. It's good for blasting. So they actually go after that quite a bit for the GSA. So we're not in that market, but just want to point out that that's their advantage. It's selling point to them at this point. How they try to do is here you see it. This is their new system. They do it, and then bring out the beam. So try to eliminate the welding in the field, right? You see it, but they still need to connect these 2 together in the beam slice. So the welding is still required when you're doing the beam splice. So free welding on the beam splice, that's a no-no. Okay, beam limitations, I mean that's pretty deep. So obviously when you do any kind of free welding, field inspection will require, and then you need to require these top and bottom to be welded over. And also, you see this one, in order to make it work, these two
On the
plates
side.
will have to match the same size
Yeah.
of the column width.
The beam, yeah.
Right, the beam doesn't matter
Yeah.
how wide, but this plate have to match this one,
Yeah.
so they could weld this to it.
Uh,
If the beam is narrower than this, then they cannot put this plate. Right, so they would have to weld this onto it. Stiffeners, there's a stiffener here that I'm talking about. So this is a stiffener on either side.
yeah.
We don't see it, so they require it on those locations. So advantages, they call extensive testing, have a ICC report as well as side plate approved. They are trying to get the 358s like us, so
Yeah.
they're in the same process and the same ballot in terms of 358 as well. So they're trying to get it into that list of document, the list of one that the engineers could pick.
Yeah.
We're trying to get into the same document at this point. So how do they engineers use it or buy it or when to use it? They would actually help the engineers a little bit because the stiffness of the connection after they weld the two plates,
Yeah.
it's stiffer than you welding the beam to the column. So they actually ask them, you could increase the stiffness a little bit. The advantage of this in increasing the stiffness is you could probably use a smaller beam when you drift.
Yeah.
Increase. You want any kind of stiffness increase. Where the RBS, the one we talk about, where you cut out the beam,
Yeah.
right? The dog bone one I showed. When they're checking drift, they have to
Yeah.
multiply by 1.1
Yeah.
because they weaken the beam
Beam.
by so much. So that's RBS, and we reduce it. For this one, they say they could increase it, so you could probably drop that or whatever. So they have to, they have the RBS to increase it. What they do is you send the email to side plate. They send you a schedule, notes, and everything back to the engineer to include it on their set of plans. So how you guys will see it, the same thing on the Kaiser boat. You'll see these side plate drawings on the set of plans. When you get it, you'll see it. So this is another SMF
Yeah.
that you're competing with. Okay, how they license it? This is, they say they charge it per square foot. So if the building is bigger, they charge you more.
Yeah.
If your building is smaller, then they charge it. So they typically charge the owner or architect or the contractor, but whoever is paying that.
But
So
if the building is too big, but just one.
they sell it for residential. They're like a
Yes.
one frame. They
Yeah.
do have it for and I'll bring their catalog as well
Yeah.
to let you see what they look like.
Yeah.
So if you go to side plate, they have that. This one is called another system is
Yeah.
a Connex Tech system. Okay, it's almost the toys kind of. You have a column, you have these beams, and you have these brackets. See this? That's how they bring it in. So here's the column. These are all welded. The brackets, whatever they call these, are welded to the column already. Then they drop the beam in. Okay. All these weldings are very tight tolerance. Actually, robots does the welding. It's all robotic welding on theirs. This, they try to do the whole system.
Yeah.
So they do the floor, they do the beam, they do the column. They actually erect the frame for you.
Yeah.
Okay.
Hmm.
This one, the engineers don't like it because they actually does all the engineering as well. So they take over the whole system.
Yeah.
So they deal with the
Yeah,
contractor
how-
or deal with the owner and an architect. The engineers no longer, they serve as the engineer for the project.
What's that connection? Kind of hard to see what it's.
See this here? That's the beam,
Mm-hmm.
and that's what it after it's put together. This connection is on. This is the top of the column. They're trying to drop the beam down. You see, they use the RBS for the dissipation, but the connection itself is just like just drop down and bolt it through.
They have the whole. Yeah.
Yeah. See, these are
dovetail connection,
Yep,
and then it's broken.
Exactly. That's what it is. It's very tolerant, its tolerance is very tight. But the thing is, once they get going, they could erect a whole building in a week.
Wow.
So cost savings for them is really coming in the fast erection time. in this.
Yeah.
So very easy, very fast to erect. But what how this is still a RBS system when you're doing how they dissipate the energy, but the connection is their proprietary connection. But they, like I say, they sell everything. What their market is mid to 3 to 10 story condominiums. So mostly condos I've seen. So they want to erect it quick. No. Very few residential is too expensive to go with, but condominiums they try to save them the erection time. That's where the most of the money comes back to. So you see this. This is actually one of their things to help to erect the building. It's very interesting. This one, they don't weld the base plate down. Okay, they don't bolt it down. They have something holding it and then erect it. Because if you weld it down, just weld it off a little bit, you can't put those beams in.
Yeah.
They have to be loose. So it's very strict. So they actually erect all the beams first, then come back and weld the base plate.
Wow.
So this one's very very different. Previously,
Now, condos that are 3, 4, 5 stories.
Yep.
That could be done in wood construction. So
there's a 9 to 10 story. They go up pretty high.
yeah, so it's really 6
Yep.
to 9 story
Yep.
tall condos. Okay.
Yeah, and these are very, fast to erect. Like they have one right in Oakland by Bartco right before you go to San Francisco, and that condominium I think is like 10 or 11 stories. You go back, almost like a week or two. That thing's everything's erected. It's fast. It's time savings compared to waiting for the concrete,
Yeah.
waiting for anything. So when you bring in a tray, this is erecting it very very fast actually. So before they were limited to these, but now they have done bigger beams and bigger columns. So the 12 beam limitation is no longer correct. I think they have their up to 24 now, and then the columns they made it bigger because more testing. They have done more testing. This presentation I put together in like 2009. So and some of them are still behind, but especially for this one, they have done a lot more. So it's really a structural component integrated system. Like I say, all these welding and the color, all these are robots, robotic welds. They feed it in, all the robots weld, you come back. So you see how much. They design it in 3D, detail in 3D, and then they'll shop and import it. Everything's done in very quick.
Yeah.
So detail in 3D, shoot it out. CNC machines, everything's done. All the welding's done in a robot.
Yeah.
No field welding required. They all bolted together. RBS, like I said, they tested with the RBS, pre-qualified it for that connection. Works with the client, the architect, acts as the structural engineer. That's why a lot of structural engineers don't like it. They just take their job away at that point. They provide design, detail, and documentation. So everything. They give you a set of drawings. They give you calculations. They actually build a building for you for this one. So they do basically everything. Cost and credit for mid-rise construction. That's what it is. Low rise, it's a couple of stories, not very fabricated and erected structure, like I said. Paco, the one you're a little bit familiar with, this another competitor of ours. This is their 1 story, 1 bay. Bolted connection. Okay. You see here's the bolted connection. Very, very similar to our OMF. Okay.
Whose old employer
Yeah.
likes this Paco system?
Yeah. So if you're, it's the same. They give you they give you what they have over us is actually probably a different base condition.
Yeah.
They offer the fixity, the hinge, and rigid connection. I don't know about you get that rigid. Depends on what foundation you have, how much you bury into it. You still base fixity. I'll go over that actually that was the whole presentation just on base fixity tomorrow. Because it relates to the base plate design and anchorage of the frame. So they sell it like very similar to ours. You're familiar with it, so I'm not going to spend too much. But Chi, if you haven't seen it, is they did the same advantage as us. They put all the nailers for them. They basically all you have to do is no field welding. All they do is bolt it together. Okay, and you drop it on the anchors. So for 1 story, they're the same. They do offer 3 or 4 multi-bay and multi-story as well. I have seen these that they're going after. For this one, their frame height span for the one story residential. These are what they are. Steel columns of 5.5 to fit within. All these are exactly same as our selling points
Yeah.
for what they have. Okay, so they did test some of the connections of Virginia Tech for that, and then they offer fixed hinge and rigid base. This is probably the biggest advantage over us at this point. If you drift typical control, then you put in a different base. And I'll show you what the difference between a fix and pin tomorrow, just by checking in the Excel SAP thing.
Yeah.
Change it from a pin to a fix. We'll see what the difference would be. Their nailers are 3x instead of ours. Depends on what location. Ours is all 2x for the old map, so that is a little different. So you can see 3 stories, 3 bay. Not just residential now. This is our light frame, so they don't attach the wood nailers a light frame. They let them weld it to the flange. We do the same thing. If they want to use it, we let them weld it to ours too. This one is a kind of Starbucks one, open front, so they supply the nailers. This one, my frame, they don't supply the nailers. Okay, so they have to do the engineer record, or somebody have to do the transfer to them, because typically this sticks out 3 inches, so it's lower than the rest of the structure. This one you can see 3 stories and many bays across. So they offer that solution as well. Beam bracing is required. They actually spell it out on their on their catalog. They're saying catalog values are based on 3-foot beam brace length. So you can brace it every 3 foot. We don't require that for the SMF. That's one of our selling points. They would have that bracing. Limited beam and column depth weights. They use their own section somehow. I don't know. I have not seen one. I haven't seen the actual section that they publish. So what it is. Field bolted offers one or multi-story application. They pre-design packages, catalog like what we have, calculation package like what we have, CAD drawing details, exact same thing. So that's why it's competing with us before. Designer to specify the drawing, Paco to sell the frames. Okay, they sell the whole frames themselves. So when you see this on the drawing, you'll know that's another SMF competitor, and they will spell it out, Paco, blah blah blah, the beam size, the column size. Those are a little bit harder sometimes to do, because when they put the Paco beam and column size, I sometimes you don't know what the exact size they are. Because the other system, they go with the W section, Y flanges, so you know what sections they are right away. So sometimes if they use the proprietary section, we don't know. It's kind of hard to convert for those. So that's the Paco. When we say engineering design, here's a document, pre-qualified connection for special and intermediate steel moment frames. Here's the booklet that engineers will pick their connections from. So the types that are included in there right now is the RBS. That's what RBS looks like. The bolted, unstiffened, and stiffened end plates are in the moment connection pretty much. Bolted flange plates. So here's the flange on the top, flange on bottom. You bolt it through. So these are the ones in there. They added a couple more. Since this one, they added a couple more connections, but these are the ones they pretty much cover at this time. And also the Kaiser bolted bracket is in the document. So you'll see all these ones the engineers could choose from and choose and pick. Okay. And then obviously ours is the special moment frame as well. And again, the yielding is the special behind our special moment frame. This is actually directly from the catalog. So we tell them, and it is, just let you know, it is patent, U.S. patent. So the whole connection is patent. We have patents in the U.S., Canada, Japan, as a whole, everywhere. I mean, a whole bunch of places where we patent the connection. So designs other than the U.S., you might see it being used in Japan, Australia, New Zealand. Those I think we have patents on. So if you have jobs or something, they might be coming from there. So I don't know. We haven't gone that far, but the patent process has been done, and we do have a patent for those locations. And I think Europe as well. We have a patent for the EU. So for ours, we offer a light, intermediate, and heavy solution. And what that means is basically just on how much the length next down. I'll show you a graphic that's got built up section by section. Very easy to see them compared to this one. A little introduction next. that will be your next presentation. I'll cover this in a bit more detail. Just a quick glance. Bolted beam to column connection, no field welding. That's where selling point. No beam bracing. Okay, it's a big advantage if you're doing some wood construction, but beam bracing is not such a big deal when you have heavy construction because they have another beam next to it.
Yeah.
You just brace it. Wood, it's hard to brace against wood. Another selling feature is the links. You could remove the links after earthquake and replace it. Our design is not to design the beam and the column to be damaged. Those are actually stay in place. Oh yeah, after an earthquake, you just replace the link, put another one, and it's good. So that is our selling point. Okay, so the ICC connection coming soon. This one report is actually end of the month, so we should get it by the end of the year. We have ICC report. The AISC 358 will be coming in mid 2013, I believe. So those we have it. What we're trying to go after, obviously residential, multifamily, and light commercial. One-story catalog offering, we have all these already. Multi-bay and multi-solution is where you guys are being, will help us out on this one. Beam and column and the link. This one, we try to sell everything at this time when we're doing the one-story, two-story. But when we have doing some like heavy steel construction per se, we don't know. Right now, I guess we do kind of know now. We offer to sell them the link at a cost, so they don't need to buy the steel beam or column from us.
Mhm.
But if they want to use us and use the AISC 358 to design, we sell them the link. And that's how we make money on those AISC 358. So we probably provide some engineering services as well for if we need analysis and design for that. If people show us, okay, here's the beam and the column, I want to use your link. And we're selling the link, we need to tell them what link size and what the bolt connection looks like. So some of that we might need some engineering service help on that, but that's down the road. These solutions won't be possible until we get into the AISC 358. So that's not till next year, and probably when everything starts flowing, will be 2014 most likely. So these are some of the offerings we'll do on how we do it. So. Review of everything else. There are many competitors in the SMF market. The biggest, I would say, competitor is probably the engineer design frames. They could choose the ones that they have. The next one is probably side plate for residential market. For light commercial market, Kaiser bolted brackets, Ladeware Paco, blah blah. Also competitors in addition to our engineer design. Our frame is the only frame that's specially designed for light frame construction. We could say that we actually design it around so beam bracing is not required.
Yeah.
Okay. And no beam bracing obviously is a big selling point. No beam bracing, and you can replace the link after an earthquake. That's the selling point. So that's it for the competitor overview. So when you see these on the drawings, you know what they look like, what they are.